Welcome to the next session of Programming for Problem Solving. The topic of the day is flowcharts. Now, what is a flowchart? Flowchart is used to visually present the flow of data in an information processing system and the operations performed in the system and the sequence in which these operations are performed. So basically, a flowchart is a programming tool. Before we start with the coding process, we draw a flowchart to try and understand how the flow in the program or the flow of the execution within a program takes place. The first characteristic of a flowchart is that it is a visual tool. So all flow within the program will be represented visually. And the second thing is that it describes the sequence in which these operations are performed. So how do we create a flowchart? Flowcharts are drawn using the standard symbols. So you have some standard symbols that are available with you, which have been standardized. So you can use those symbols. In addition to those standard symbols, you can also use your own symbols as per the requirement. Now, what are the different advantages of a flowchart? The first advantage of the flowchart is communication. Now, when you draw a flowchart before coding the program, you want to express your idea to other people. Now, it is easy to express the idea and convince other people and make them understand the problem. Flowchart provides a visual communication which is easy for others to understand. So the communication becomes much easier while you use the flowcharts. Effective analysis. Flowcharts help to analyze the problem in more effective way. You are able to understand what is the actual requirement, where you need to put which symbols, and then how the program is or the flow is actually working. It is easy to analyze it. You are able to analyze it just like the flowing water. You are able to see the flow of the execution from where the program is starting and where it is moving. Proper documentation. It's a very important documentation tool. Before starting with the code or any project, if you have developed flowcharts for every program, sometimes it is not easy for a new person to come in and start reading the program directly. So they can look at these flowcharts at any time and try to understand what is the basic idea behind designing of the program. Effective coding. Efficient coding basically means if the flowchart is ready, the programmer does not need to apply any logic. It simply needs to follow the execution flow that has been defined in the flowchart. So where to place which type of code, where to use sequential programming, where to use conditional programming, where to use iterative loops, everything is easy to understand for a programmer through flowchart. Easy debugging. Now, if your program or the flowchart is not giving you the right answer as per the expectations, then it is easy to debug the exact spot where the problem is. Because you can start from the first point and you can just follow the directions in which the flow is moving, it is easy for you to trace where exactly the things are going wrong. Different disadvantages of the flowchart. Complex logic. Now it is okay to draw a flowchart for a smaller problem which is not relatively too complex, but then flowcharts can be very difficult to generate for very large projects, and it can become very difficult to express the ideas using the flowchart for bigger projects. So you have another concepts like pseudocode, class diagrams, and many other things that you can use to express those. So flowcharts are basically used for the problems which are smaller and lesser complex in nature. Difficulty to modify. Because it is a visual representation, all the components are placed one after the other. in case you need to modify or make any changes into it, it becomes very difficult because the whole structure has to change. Nothing is independent of the other components. So all the components are getting affected if you want to make a change. More stress on technical details. The essentials of what is done can easily be lost in the technical details of how it is done. So the more stress we are putting on the technical details, we are not trying to understand the basic idea behind how we are going to do it. So it is one of the bigger disadvantages of the flowcharts. Difficulty to maintain. Without the use of programmed or automatic tools, it is time consuming to maintain logic flowcharts. You cannot just simply pick up a pencil or a pen and on a paper you can draw a flowchart and then keep it with you. You want these flowcharts to be with you all the time, and you want to make them very fast. You do not want to use the tools which are not meant for creating the flowcharts. So it is only appropriate that you use the tools which are meant for drawing the flowchart and you are able to maintain them. Because of its nature, these flowcharts are not easy to maintain. As I said that the changes are very difficult. In future, if you want to make any change, you have to draw or make the flowchart all over again. This is the list of different symbols that are used in the flowchart. The first is representing a rectangle shape. As you can see here, it represents a process. So what is a process? Basically any type of operation that you perform, like A is equal to B plus C. This is an arithmetic operation or a process that we are performing. So this can be pictorially represented with the help of this symbol, rectangular symbol. So this rectangular symbol is basically used to represent or indicate an internal operation. Next is this shape. So basically what is this shape? This is used to define input and output. You accept the input from the user, apply some kind of process or operation on it, and then you display the output. So the two components of a program, input and output, are vital. Accepting the input from the user and giving back the answer to the user. So for that you can use this symbol. What is this symbol? It indicates the input or output of the data. The third and very important symbol, as you can see here, this symbol is used for representing a decision. What happens is sometimes the flow of the program is not sequential in nature. That means the instructions are not necessarily followed one after the other in a sequential manner till the end. Sometimes the execution of the instructions or the flow of the program depends upon the outcome of some condition. Now, how to ascertain the outcome of that condition? For that, we use the decision symbol. For example, is A greater than B? Now, this is a decision that we need to take. What are the possible outputs of this decision? Yes or no. Yes means A is greater than B. No means A is either equal or less than B. So for representing such decisions, we use this decision box. So there will be two outputs from this box. One will have the label yes and the other one will have the label no. Next, we have this symbol as a circle or an oval. This represents a connector. Now, what is a connector? Sometimes the size of the flowchart becomes so big that it cannot be viewed in a single sheet. So when a flow line actually moves out of one snapshot, then we name it as a connector like A within the circle. And in the second sheet, we can again use A to show the connection between the flow line in the previous sheet and the new sheet. So what is this? This is showing the intersecting of the lines. Next, what we have are the remaining symbols that we use in the flowchart. So what is this first one representing? This is representing a subroutine. Now what is a subroutine? Basically this is also a process, but it is different from the process symbol that we saw in the previous slide. That process is used to represent, or that operation is used to represent the operation that are contained within the flowchart that you are creating. That means अगर आपने एक प्रोसेस को बनाया है या आपने एक ऑपरेशन को डिफाइन किया है उसी फ्लो चार्ट के अंदर जिसमें आपने उसको यूज किया है, then you use a simple rectangle. Now then why we use this particular symbol? This is used when you have defined a process in some other flow chart or somewhere else, and you want to use that process in your own flow chart. So basically you are including a predefined process into your flow chart. For that you use symbol. Next, what we have is an oval. So what we had in the last slide was a circle, and what here we have is an oval. This is used to indicate the beginning or the end of the flow chart. So basically we are going to start with using this symbol and we will label it as start, and where we reach is called the end and we can label it as end. So we use the oval shape to basically indicate the beginning and end of the flow chart. The last symbol that you can see here is the most important symbol of the flow chart, because the name of the flow chart or the tool actually is dependent upon this. These are called the flow lines. So what they represent is the actual flow of the execution of the proposed program. From where it is going to start, what will be the next step, what will be the third step, if it encounters a condition, where it will go. All these are represented with the help of the flow lines. Flow lines can move downwards, upwards also to show the repetition. They can move towards the left side and the right side. So all these lines will be used to represent the flow of the execution. So here we are going to start with the sample flowcharts. The first flowchart that you see here is to determine if the given number is even or odd. So most of the symbols have been used here. We will see from where we are starting and which all symbols we have used in this particular flowchart. To begin with, we will start from here. As you can see, we are using the oval shaped symbol. This is used to indicate the start. So basically no operation is being indicated, no operation is performed here. It is only indicating that we are going to start. So here next you can see is the flow line. So we are moving from start and we are moving downwards. The next we have used the symbol that is used to indicate the input or output. So the program is to find whether the given number is even or odd. So we can do that for a given number by accepting the input from the user. So whatever information the user will enter, that information will be stored in this particular variable. So number basically represents the number for which we want to find if it is even or odd. Then again, this flow line indicates that we are moving towards the third symbol. So this is a third symbol that actually signifies, or it represents a process or an operation. So we are going to perform some process here. What we are going to do is we are going to find the remainder of the number when divided by 2. So if we have 5 and we divide it by 2, the remainder will be 1. If we have 4 and we divide it by 2, the remainder will be 0. So what's the idea? The idea of this process is to find the remainder of a given number. And then again, using the flow line, we move towards the decision symbol. So where is this decision symbol? So this is all important symbol in this flow chart. What is the value of the variable remainder? The value of the variable remainder can be either 0 or either 1, and we are trying to check if the value of remainder is 0. If the value of any number divided by 2 and the remainder is 0, it means that the number is a even number. So you can see, is remainder equal to 0? If the answer is yes, then we take this flow line and we use this symbol to display that the number is even, and eventually we reach the end. So this is the path that we are going to follow in case the remainder, the value of the remainder is 0. So we check the value of the remainder is 0, the answer is yes, we follow the flow line on the left hand side, display that the number is even, and we reach end. Now, what if the value of the remainder is not 0? What if the value of the remainder is not 0? The output is no. Then we are going to follow this particular data flow line and display that the number is odd and reach the. So basically we have two paths to reach to the end. One is on the left hand side and one is on the right hand side. Which path we are going to follow will depend upon the outcome of this particular symbol. If the outcome of this particular decision is yes, we will follow this particular path. And if the answer of the decision is no, then we are going to follow the path on the right hand side. I hope this is clear to you. So now we will look at the second example. The second example is to find the sum of first n numbers. For example, we want to find the sum of first 5 numbers. So again, we are going to start from the very first symbol, which is used to indicate the start of the flowchart. So this symbol, as you can see, is available right at the top as a circle, as an oval, sorry. So this is the first symbol that indicates that we are going to start. Once we process this, then using this flow line, we move towards the second symbol. What is the second symbol? This symbol is used to accept the input. So this input here is n. N is 5 because, as I said in our example, we are going to find the sum of the first 5 numbers. So n is equals to 5. So we can write here that n is equal to 5. And then we are going to reach this particular symbol. Now what will happen here is, because we are going to start with the counting, the value of the variable num is equals to 1 and sum is equals to 0. Then we move towards this next process. What is this process? It will add the value of number to the existing value of sum. What is the existing value of sum? It is 0. And what is the value of existing value of num is 1. So 0 plus 1 becomes 1. So new value of sum will become 1. Num is equals to num plus 1. That means we will increment the value of num by 1 and it will become 2. Now check the output of this particular decision table. Is n greater than equal to num? The answer is yes. N is 5 and num is 2. So that means it is true. True means we will move back to this particular process. Sum is equal to sum plus num. So that means sum will become 1 plus 2 is equals to 3. And then num is equals to num plus 1. So num will become 3. Again check the condition. The answer is true. We go back to this particular process. And then we again add 3 plus 3 is equals to 6. and increment the value of num is equals to 4 right here. Again, check if the value of n, that is 5, is greater than or equal to 4. The answer is yes. We will again follow this particular path and then again increment the value. Sum becomes 6 plus 4 is equals to 10. Now again increment the value of num becomes 5. Again the outcome is true. Sum is equals to sum plus n, so sum becomes 15. And increment the value of number to 6. Now check this condition. N is greater than equal to num. What is the value of n? 5. 5 is not greater than or equal to 6. That means we are going to follow this particular data flow line which says no, and we are going to display the value of sum. What is the value of sum? The value of sum is 15. So what is 15? 15 is the sum of first 5 natural numbers. So let's move towards our last example. Our last example is to find the factorial of any number. So what is a factorial of number? Let us suppose that we want to find the factorial of 5. Then the factorial of 5 is 1 multiplied by 2 multiplied by 3 multiplied by 4 and then multiplied by 5, which turns out to be 120. So what is the factorial of 5? The factorial of 5 is 120. What is the factorial of 3? The factorial of 3 is 1 multiplied by 2 multiplied by 3 is equals to 6. So this program is basically used to find the factorial of a number. The first symbol, as you already know, is start, which is an oval shape. The second symbol is used to indicate the input n. So n is the number for which we want to find whether it is factorial or not. So what will be the initial value of n? N is equals to 5. So n becomes 5. So the next is an internal process with which we are initializing two variables. One is called num1, which will be equal to 1, and one is called fact, which will also be initialized to 1. So what is fact? Fact is the variable that will contain the final value of the factorial of 5. The next is an internal operation which says fact is equals to fact multiplied by num. So 1 multiplied by 1 will become 1. The next is an internal process which indicates num is equals to num plus 1. So the next value of num1 will become 2. Check if the value of n is greater than equal to num. The answer is yes. To keep the things short, we will keep the value of n is equals to 3. So check whether 3 is greater than or equal to 2. The answer is yes. So we go back and recompute the value of fact. What is the value of fact? Fact is equals to fact multiplied by num. Fact is equals to fact multiplied by num. That means 1 multiplied by 2 and it will become 2. The next is an internal operation. Increment the value of num by 1 and it becomes 3. Now check whether n is greater than or equal to num. Now 3 is not greater than 3, but it is equal to 3. That means it will return true and you will again recompute the value of fact. Fact is equals to fact multiplied by num, it becomes 6 and we increment the value of num by 1. Now check whether n is greater than or equal to num. The result comes out to be no. Once the result comes out to be no, then what will happen is that you will follow the data flow line which is labeled as no. And once we followed this data flow line, the next symbol is an output symbol to display the value of factorial. So what is the value of the fact variable? The value of the fact variable is 6. And the last we reach the end symbol. So this is how we can design a flowchart for the computing problem to find the factorial of a given number. I hope that you were able to understand what is a flowchart, what are the advantages and disadvantages of a flowchart, what are the default or the standard symbols that you can use to draw a flowchart, and then with the help of some examples, you were able to understand how eventually a flowchart can be designed for different problems. But working with only three flowcharts is not enough. I requesting you all to try and design flowcharts for many different problems, like finding the or drawing the Fibonacci series, or finding whether a given number is prime or not. So problems like this, please look into these problems and try and design the flowcharts for the same. Thank you very much.